Okay, this is paired test scenario 2. Professor Andy McNeil measured the time in seconds required to catch a falling meter stick for 12 randomly selected students, dominant hand and non-dominant hand. Professor McNeil claims that the reaction time in an individual's dominant hand is less than the reaction time in their non-dominant hand. So he's saying that dominant hand is less than a non-dominant. Okay, test an appropriate hypothesis and state your conclusion. Well, we notice we have students 1 through 12, and we have dominant hand and non-dominant hand times, and we're saying they're faster this way, or we're saying non-dominant hand is less, and if it's less, you're faster. And just real quickly, if someone does something in 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, if it takes someone 1 minute to do something, they're faster. So the smaller the number, the faster you are. So we have 2 lists of data, and it says test an appropriate hypothesis. Well, each one was tested twice. Because each one is tested twice, we can run a paired test, which means we're working with a mu-d. Anytime we're working with a mean difference, our null will equal 0. And in this case, what they told us is McNeil claims that the image is less than. So this tells me that we're working with a less than symbol. Mu-d is less than 0. So let mu-d equal the true population mean difference in reaction time. And we went dominant minus non-dominant because that's the way it was listed. Dominant minus non-dominant. We always have to include which order we're subtracting. And we're expecting it to be less than 0. All right, conditions, which is the next thing. Well, that's just assumed. We don't have to do anything about that other than write assumed. I should have said mean difference. We have to use that phrase, right? So mean difference, and we have to give the order that we subtracted. All right, so conditions are assumed. There they are. I made a box plot of the data, and that's about the same distance. So 50% is about equal to 50%. So it looks pretty reasonably symmetric. So we're going to say it's normal enough. But once again, these 4 we can skip. We can just write assumed. And then we have our formula. Well, our formula is T equals X bar D, the sample mean difference, minus mu D over SD divided by the square root of N. And we need to write down what we need. We need mu D, which happens to be 0. We know that. We don't have X bar D. We don't have SD. We do have N, which in this case is we have, even though we have 24 data readings, we only have 12 pairs. And so N is the number of pairs I have, which is 12. Okay, so the shortcut to getting this information is to go ahead and enter this data. And we're going to enter this data into L1 and to L2. So dominant and minus non-dominant, because this was going to be L1 minus L2. So here's the way you do that. You go to stat edit. So stat, press edit and enter. Now, if you have columns left over, just go to the top, like just arrow all the way up to the top, press enter, and then clear. And maybe enter again. And it should clear it out. You may have to press enter a couple times. So up to the top, clear, enter, should be clear it out for you. So I've already entered my data into L1 and into L2. And I'm going to, now I need to subtract them. So basically I need to subtract all these individual values. And so I'm going to go second 1 minus second 2. And there, it populated it out. And you can see some are positive, first one's negative, etc. And then I'm going to need to take the average of this and find the standard deviation of this third column. So I'm going to go stat, over to test, and I'm just going to go ahead and run that t-test. Make sure data is highlighted. If stats is highlighted, just arrow over to the left, press data, mean is 0, list is L3, And in our case, we had a less than. And the reason, that's what they told us, less than. So I want to keep that less than, and I'm going to press calculate. I get a whole bunch of information, but some of that information is X bar D equals negative 0.01316, and also get a standard deviation of 0.0164. All right, so negative 0.0131 and a standard deviation of 0.0164. All right, and I just wrote that down and filled that into my filled that in down here. Now that I filled it in, and I also calculated my t statistic. So I might want to write that down because I'll use that in a little bit. T equals negative 2.7759, and I also got a p-value of 0.0009, which is pretty small. So I plugged in my values here. I plugged in the negative 0.0312 right here, minus my mean of 0, my 0.0164, and my sample size of 2. That yielded a t-statistic less than negative 2.776, which equals this p-value. They didn't give me a p-value, an alpha, so I'm going to use 5. And since I have 0.009 here, I'm going to make these the same length, 1, 2, 3, 1, 2, 3. And 9 is definitely less than 50. With 9 being less than 50, we're going to reject. So our p-value is 0.009. We reject the null. There is sufficient evidence at alpha equal 0.05 to suggest the true population mean difference in reaction time. The order is super important, is less than 0. The less than 0 is because that's what we said here. Less than, so less than 0. So basically, Professor McNeil is correct. Correct. Professor McNeil is correct. The dominant hand takes less reaction time. They're not the same. The dominant hand takes less reaction time. All right. In the next video, we will do the confidence interval for the same test. Thank you.